In this lesson, we're going to be looking at combining areas of different shapes into what we are calling composite figures. If you think about a composite, it's a mix of different things. So we're mixing different shapes to create these irregular shapes. So basically what you have to do is you're going to take a look at the pictures and think about the pieces, right, that make up the picture. So for example, if I look at number 1, I'm going to see, well, this shape doesn't look normal, as in like a square, a rectangle, rhombus, kite, or something I know how to solve for. But I can see, hey, it's made up of this little half circle, right? And then on the bottom, I'm going to see this trapezoid. And I know how to find the area of those two separate pieces. And all I have to do is find those areas and put them together. And something I like to do sometimes is to actually just take apart the picture and then calculate those areas separately. So if I've got half a circle here, I'm going to start off with my formula just like I normally do. So area is pi r squared. But I don't want all of it. All I want is half of it. So I'm going to divide it by 2 because it's a half circle. And since the whole diameter is 20, the radius is 10. So I'm going to go ahead and plug this in to my area formula. So area is pi times 10 squared over 2, which is going to give me 50 pi. Okay? So then I want to look at that trapezoid and think, well, how do I find the area of the trapezoid? Well, remember my area formula is 1/2 of B1 plus B2 times H. And then I've got my two parallel bases, 20 and 32, right? So I get 1/2 of 20 plus 32, 32, times the height, which is 14. And doing all that math, I'm getting A equals 1/2 of 52 times 14. And that should give me a total of 364. Now, those are the two separate pieces. So to find the total area, what I want to do is I want to combine them. And what do you think we're going to do to combine it? Well, we're just going to add it, right? So we're going to do 50 pi plus 364. And let's go ahead and round that to the nearest tenth. So I get 521.1 square millimeters. All right. Take a look at number 2, and why don't you tell me what kind of shapes you see? Well, everyone sees something different, so let me show you what some possibilities are, and they're all going to work out the same as long as you just break it apart. So some people see a parallelogram, right, and one large triangle. I've had other people see a trapezoid, a small right triangle, and a large triangle below. And you'll see it doesn't matter what kind of shape you see as long as it all comes back and adds up to the same shape. Okay, and finally what I've seen people see is again the trapezoid, the little right triangle here, a right triangle down there in the middle, and one final little right triangle on the edge on the bottom right. And that works as well. Again, all you have to do is find the areas and put the pieces together. So go ahead and try that out using whatever shapes you saw, as long as they're shapes that we know the formulas for. So the way I saw the composite shape was I actually saw the parallelogram and the triangle below. So I'm going to go ahead and just work that one out and show you what I got from my composite area. So for the parallelogram, we know that the area formula is just base times height. And since I've got the perpendicular base and height right there, I'm just plugging in 8 and 5, and that's how I get 40. And then the bottom triangle, I know that the area formula is 1/2 times base times height. And once again, I've got that perpendicular height and base going on here. So I plugged in 10 for the base and 5 for the height to get area 25. Now remember, for the composite shape, I just have to put it together. So my total area is just equal to 40 plus 25, which is 65 square feet. So all we do to find composite area is find the area of the shapes we recognize and just add it together. So again, all we're going to do is find the areas of the shapes you recognize and then add the areas, just making sure you don't pick overlapping regions. And again, these are what we call composite figures. Okay, so once again, these are for the shapes where you'll see, shapes on top of each other, shapes that are stacked together. So if we look at the next section, what happens if it looks like, something came in and took a bite out of my shape? What do you think we're going to do here? Well, if you have a hole in it, we're not adding to the area. What do you think we're doing? All right, we're going to be taking away from the area. So we are going to subtract here. Okay, so that's our game plan. We're going to subtract the area of the white space from the entire shape. All right, so why don't we do number one together? So first off, you want to think, well, what is that whole shape? If I ignored this circle and thought, well, if everything was filled in, what would that be? Well, that would be a triangle. So again, if it helps, you can always draw your shape separately. And here I've got 26 and 18. I don't really care about that hypotenuse because once again, the base and the height need to be perpendicular. So, area, 1/2 base times height, plugging in 26 and 18, we should get an area of 234. Okay? But I want to actually take away that hole because in reality I don't have the whole triangle. So now we want to think, well, what is this shape and how do I find the area of that? Well, that is a half circle like we saw in that first number one. So I'm going to take my area formula for a circle, that pi r squared, I'm going to divide it by 2 because it's a half a circle. If it was a whole circle, I would leave it as pi r squared. And since the diameter is 9 feet, we know the radius is half of that, which is 4.5. So I'm just going to go ahead and plug that in. So area is going to equal pi times 4.5 squared over 2. So that area is going to be about 31.8. Okay, and then of course to find the total area, all we're going to do is do our game plan and subtract. So total area is the triangle minus the semicircle, the half circle, and that's going to be approximately 202.2 square feet. So that's 202.2 in case you can't read that. All right, go ahead and try out number 2 and let's see what you get. And you can check with my answer in a little bit. So I'm going to block this off so you can see my work. All right, so did you see how that whole shape was a circle? And the diameter is 20, which makes a radius 10. Well, then I just plug it into my circle formula, A equals pi r squared, and I get 100 pi. And then our hole that we've cut out of it is a trapezoid. So remember your trapezoid area formula, A is 1/2 times B1 plus B2 times H. And remember, B1 and B2 are those parallel bases that never touch, so that's 12 and 20. So I'm just going to go ahead and plug in 12, 20, and 8 for H, because that's the perpendicular distance connecting to the bases. And I get 128 as the area of the trapezoid. Now remember, we're going to take whole shape minus the white space, and we'll get our total area. So circle minus trapezoid, 100 pi minus 128, is about 186.2 square centimeters. All right, so that's really it for composite shapes. You want to take a look and see, do we have a hole cut out of it? Or, like above, do we stack them on top of each other? We're going to add, subtract, or maybe even do a combination of 2 if we're up for that challenge, right? So we'll just look at that shape and look carefully at the shaded regions.